So when we're doing M, it's a little different. So notice on my M, I made little tick marks on the graph on the x-axis. I made little red tick marks on there. The reason I did that is because that's where the point is, right? That's where the height is determined, that x value, right? With LRAM and RRAM, it was the left side or the right side, right? That determined how tall each bar was, right? The left side or the right side. For the L, the left side of the rectangle determined the height. For R, the right side of the rectangle determined the height, right? Well, for MRAM, it's the middle. Neither left or right, it's the middle. So how are we going to find that height of the first one? How are we going to determine the height? We know the width, right? It's 1/2, right? So the first width is going to be 0.5. That hasn't changed, right? It's going to be 0.5 for all 4 rectangles. But the heights have changed, right? The heights have changed. So how are we going to find the height, for example, of the first guy? What can we do to find the height of the first rectangle? I'll give you a hint, you're going to use the tick mark the red tick marks that I drew. You're going to use those. What can I do to use, how do I use those to find the height? Mhm. Exactly, yeah, that's how I made the dot, right? That's how I determined the height of each, right? So my question is, how do I determine that point there? How do I determine the point? Well, the x, right? The x is 1.25, right? How do I determine the y? Because the y is going to tell me my height, how tall it is. So what can I do to figure out the height? Yeah, plug it in. Plug it into the function, just like we did for earlier, yesterday. So the first one, it looks like x is 1.25. That's determined the height. So I'm going to plug in 1.25 for x. The function is at the top of this page. I'm going to see what I get. Okay. So 1.25 squared is 1.625. 1.5625. 2 times 1.25, it's like $1.25, double $1.25, that's 2.50. 2.5. So subtract that and then add 2. I get 1.0625. So you should always kind of check to see, does that make sense? Am I way off? Did I do something wrong? And no, it kind of, this is just above 1. And it looks like this guy goes just above 1. I mean, just barely above 1. So that seems okay. So now that's the height. So I'm going to include that, 10625. Okay. That's the first rectangle. The second one, it looks like it's the same thing, but at 1.75, right? This is 1/2. This is 1, 1.25, 1, 1.25, 1.5, 1.75. So at 1.75, I need to find the y value. So I'm going to do the same thing, but now for 1.75. Okay. Oops, 1.75 to the second power 3.0625. 2 times 1.75 is 3.5 plus 2. 3.0625 minus 3.5 plus 2. 1.565. Let's go back up on the graph to verify that that looks right, and that looks about right. Looks like the height's just above 1.5. Okay, so I'm going to include that in my table now. 5.625. Okay. Last two. Okay, the last two are going to involve 2 point something now. So this guy here, so let me shade the ones we've done so far. So we've done that one and we've done that one. So now I'm on the third one. This is 2.25. So 2.25 determines the height. .25 squared minus 2 times 2.25 plus 2. 2.25 squared is 5.0625 minus 2 times 2.25, which is 4.5 plus 2. Plus 2, I get 2.5625. Okay, I'm going to go verify that to make sure it's about 2.5. The height's about 2.5, just to make sure I didn't do anything wrong. And nope, it looks like the height's just over 2.5. So that's right. 5.625. Okay. And then the last one, the height of the x value for that one is 2.75. So 2.75 determines the height. It looks like right at 4. It looks like right dead on at 4. But again, the rest have been decimals, not close decimals, like 1.0625, 1.5625, 2.5625. So I'm not going to take a chance that it's 4. Might as well be certain. Plus 2. Okay, so last time. 7.5625, that's 2.75 squared. 2 times 2.75 is 5.5 plus 2. And turns out it's just above 4. 4 would be a good approximation, but we're already approximating. So we don't want to approximate even more, especially when we have the capability of finding out what it is. Okay, so that's going to be the last one. Last thing, multiply and add. Since they all 4 have a 0.5. A shortcut, I guess, is adding these guys here and then multiplying all of them by 0.5. That's a shortcut if you want to do that, or you can just do all of these and add them together. That's factoring out a 0.5. It's just, you don't have to, it's just It's a shorter way. Plus 2.5, 625, 4.0, 625 times 0.5, and I get 4.625. 4.625. So that represents all four of the rectangles. Okay. Now they're all approximations. They're all approximations. One of them's under approximation, one is an over approximation, and one's closer, but still approximation. It's not exact, right? How do we do it exactly? That's what we need to use the fundamental theorem of calculus, which I'll show you guys next week. Okay, so right now we're just approximating the area under the curve. That's all we're doing, using rectangles. Okay, that's all we're doing. That's all we're doing in this lesson. Eventually, like I said, I will show you the exact, how to do it exactly. But for right now, we're not worried about that. Okay. All right. Okay, so now the next example. Selected values of f of x are shown in the table below. What is the midpoint Riemann sum approximation for? So here are our bounds. This is our bounds. It goes from 0. We have to find area under the curve from 0 to 8. Those were the bound. That's where the bounds are, right? This should look familiar. This little S type guy, that should look familiar, right? We saw that with antiderivatives, right? Again, it means integrate. So what we're doing is integrating, just using a different method. Okay. So we got to use 4 intervals, 4 subintervals, as indicated by the table. Okay. So these are all points on a graph. You wanted to graph them, you could. Right. 0, 21, 122, so on and so forth, right? You could graph them, but we don't need to because this is essentially the same idea, right? So what we do is we need 4, so they want, let me highlight some things. They want a midpoint Riemann sum approximation. A midpoint Riemann sum, that means rectangles. And that means they want us to use MRAM. Okay, that's indicating MRAM there. Okay, they want us to use 4 rectangles. 4 rectangles. So using those points, what is the width of our rectangles going to be? What do you think the width of our rectangles are going to be? 2. Yeah, 2. Now underneath where it says, I started off with not an easier one, but a less complex one. See where it says 4 subintervals? Doesn't say equal subintervals. So sometimes what you'll have are widths that aren't the same. That's okay. That's okay. This one worked out perfectly because my bounds go 8 wide, right? And I need 4 rectangles. So it worked out 2, right? Perfectly. They won't always do that way. I think the next example, I'll show you that. But sometimes they'll do that. So we'll talk about that in the next example. But for right now, so 2, right? So my first rectangle goes from 0 to 2, right? My next rectangle goes from 2 to 4. My next rectangle goes from 4 to 6. My next rectangle, my last one goes from 6 to 8, right? I have 4 rectangles. So the bounds from 0 to 8 for f of x dx So I'm going to do exactly what I did on the last one. What's the height, or what's the width of each of the rectangles going to be in this case? We said we just said it. 2. So 2 times plus 2 times plus 2 times plus 2 times. Right? Okay. First rectangle. The first rectangle. How tall is the first rectangle going to be, and how do we know? How tall is the first rectangle going to be, and how do we know? I'll give you a hint. How tall is the first rectangle going to be? So the first rectangle goes from 0 to 2. It's right here. From 0 to 2. And it's MRAM. So do we know how tall the middle between those two is? Do we know the y value of between the middle? Yeah, we do right there, right? 20. Left, if I was doing LRAM, it would go 21, right? If I was going RRAM, it would go 15. But they want MRAM, which is in between those 2 points, in between 0 and 2. So that's going to be 20. Exactly. So the first height is 20. The next one goes from 2 to 4. The middle is 3. The height for 3 is 14. The next one is from 4 to 6. The height of that one is determined by the middle again. The middle is 5. The height at 5 is 12. And the last one would be 5. So last thing, add them all up. Multiply, add them all up. 40, 28, 24, 10. So is that 50 plus 52, 102? Double check my math. I did that fast. Okay. All right. So sometimes this guy is actually easier than the graph, right? Because everything is given to you there. Everything is given to you. Right? We didn't have to calculate. The only thing we calculated was the actual heights and everything there. We didn't have to calculate how tall it was like we did for the graph. Okay. All right, let's look at this guy here. Okay. Similar question, but now we're looking at LRAM. LRAM. Okay. 3 subintervals from 2 to 12. So how wide is our bounds, overall bounds? Not each rectangle, but overall. How wide are each the bounds, I should say? How wide is the total section we need to find the area of? 10, right? 10 units from 2 to 12. How many rectangles do we need to have? 3. Here's where we run into a situation. 3 goes into 10 3.33333 times, right? So that's where I told you guys last time about the last question about these don't have to be equal. It doesn't say anything about the subintervals being equal. So this one is going to have rectangles that are not the same width. Some of them might be, some of them won't be. It's okay. It's okay. Sometimes they'll say, has to be 3 equal subintervals. That means they all have to have the same width. This one doesn't, so we don't have to worry about that. So they kind of set it up for you. First one is going to go from 2 to 6, then 6 to 10, then 10 to 12. So the first rectangle, what's the width of the first rectangle going to be? What's the width of the very first rectangle going to be? The width. 4. 4. What's the width of the next rectangle going to be? 4. 4 again. What's the width of the last rectangle going to be? 2. Okay. All right, so let's do it. Let's set it up. So we got to go from 2 to 12 for this function. So the first rectangle is going to be 4. Width of 4, the next one, and then the last one's width of 2. So what's the height of the first rectangle? Yep, 21. We look at the left side, right? We don't have a middle. We don't need a middle on this one. We don't need a middle, right? The middle would be 4, but it's not MRAM, so we don't need a middle. But we do need a left side. So 21 will be the first one. The next one's going to be 4. And the last one will be 3. 5 is the only one. 5 is the only y value that doesn't get to be a height because it does not need it. Okay. So we got, what do we got here? 84 plus 16 plus 6. Was that 106? All right. That's the left RAM, LRAM approximation. Okay. All right, so we got 2 more. 2 more, and we might have enough time to finish. Okay, so the last one. F of x is x squared. That's the function, right? It's a parabola. If 5 subintervals of equal length, so now they're saying the widths have to all be the same. Okay, the widths have to all be the same, and there has to be 5 rectangles. Yes. Are used. What is the value of RAM? Okay. Now they don't give us a table, they don't give us a graph, but they do give us a function to use, right? The first question, they gave us a table, they gave us a function, and they gave us a graph, right? Then the other ones we've just done, they just gave you a table, nothing else. This one, they're going to give you no graph. I mean, you could graph it. It's x squared. It's not hard to graph. And they've given you just the function. Okay, so what's the first thing we got to do? Figure out what. So this is what I got to do. 1 to 3.5 for x squared dx. So I need 5 rectangles. 5 rectangles. Okay, 1, 2, 3, 4, 5. Okay. What are the widths of each of those rectangles going to be? What are the widths of each of those rectangles going to be? And how do I find that out? How do I figure out what the widths are going to be? I know I need 5 rectangles. I know my bounds go from, I start at 1 and go to 3.5. So just the area between 1 and 3.5, right? I know I need 5. And they all have to be equal length, equal width. Yes, sir. Exactly. How'd you get that, Roman? You're right. Perfect. That's it. That's the easiest way to do it. That's the way I suggest do it. How wide is your bound, and divide by however many pieces you need. However many rectangles you need. So each one's going to be 0.5. Okay, so let's do 0.5. So this is RAM. Sometimes it helps to graph, to draw a picture. Sometimes, it's up to you. You could draw a picture of this one because it's x squared. It's not hard, right? It's easy to draw. You only got to go from 1 to 3.5. It's not like you have to draw a big graph, just the positive side starting at 1 into 3.5. So my question is, how do I figure out, or how tall is the first rectangle going to be? How tall is it going to be, and how do I figure that out? The first rectangle. Because I have a feeling once I figure out how to do the first one, the rest of them are going to fall in place. So how do I figure out how tall the first rectangle is going to be? There you go. Yeah. The first rectangle starts at 1. It's 0.5 in width. And it's RAM. So the right side determines it, right? So we just got to figure out how high, what's the Y value for 1.5? Okay. So let's plug in 1.5. to the function, which is x squared, right? That gives us 2.25. That's the height at 1.5. 2.25. Good. Let me draw a picture. Make it a little easier of what I'm talking about. So we're looking from 1. Make it a little more. Let's see. 1, 2, 3, 4. 1, 2, 3, 4. So this is 1, this is 2, this is 3, and this is 4, right? So we're going from 1 to 3.5. So at 1, if I plug it into x squared, 1, 2, 3, 4. If I plug in 2, that's 4. 2, 3. Kind of looking something like that. Right, and we have to find the area under the curve from here to here. Okay. It's not the best graph because it runs out of room quickly, but it gives you an idea of what we're doing. Okay, so from 1 to 3.25, or 3.5, sorry. Okay, so the next rectangle, how tall? How do we figure out how tall the next rectangle is going to be? At 0.5, right? So the first rectangle went from 1 to 1.5. The next rectangle is going to go from 1.5 to 2. The right side is going to determine, so that's 2 squared. That one's easy. 4. And then we go from 2 to 2.5. 2.5 is now going to determine 2.5 squared is 6.25. That's not a bell. That's not even the shuttle bell. We still got 10 minutes. We'll finish this question at least. Okay. So we go from 1 to 1.5, 1.5 to 2, 2 to 2.5, 2.5 to 3, that's 9, right? 3 squared is 9. And then the last one's 3.5, 3 to 3.5, right? And that's the edge of the bound, the right edge of the bound. So 3.5 squared, 12.25. Right. So now we add up, multiply and add up. And I get 16.875. Okay. Okay. We're not going to do this one because this one's going to take longer than 9 minutes and we only got 9 minutes. But look at it. How is this one different than the one we did right before? It looks very similar, right? It looks very similar. Give us a function, four subintervals of equal length. What's the difference between this one and the last one? Now they're bringing in trapezoids, right? Trapezoids. So before we were using rectangles. Now what we're going to be using, we'll do this tomorrow, is trapezoids. So rectangles, we built rectangles like that, right? We've been building rectangles like that. Now what we're going to do is build trapezoids. Trapezoids that look like this, right? So we're going to be finding area of trapezoids. So I'll give you the area equation because the area equation is a little different. So when tomorrow we can hit the ground running for this one. So area of a trapezoid is, there's got a couple different ones. I'll give you both. Base 1 plus base 2 divided by 2 times the height. I've seen that one. I've seen 1/2 base 1 plus base 2 times the height. They're all equal. They're a mixture of the equation for area of a trapezoid. It's kind of a mixture of the area of a square or rectangle and the area of a triangle, right? It's got the 1/2 type part. It's because that's a trapezoid. A trapezoid is a rectangle with a square on top, or with a triangle on top of it, right? So when we're finding area of trapezoids tomorrow, this is what I'm talking about when I say base 1 and base 2. So this guy is going to be base 1. The shorter side is base 1, or it doesn't really matter, but I usually say the shorter side is base 1. The shorter height, I should say. The longer is base 2. The height is actually going to be down here. The height is actually here. So in our case, the height is actually the width. Okay? So that's what we're going to do. So that means we need to find how high the left side goes up, how high the right side goes up, add those together, multiply by the width, right? And then take half of it. Okay, so it's essentially the same exact thing, but instead of building rectangles, we're building trapezoids. And trapezoids will do a better job of approximating because they're trapezoids, right? Look up here real quick. Look at this guy here. Wouldn't a trapezoid be perfect for this guy? Right? Trapezoid like that. Right? So a trapezoid might do a little better job. That's why we do trapezoid. So that's the last thing we're going to talk about, okay? So tomorrow we'll finish that, and then I'll give you some time to start the assignment in class. Okay, that's what we'll do tomorrow. We'll finish this, and then the rest of the time you'll have to start the assignment, and that's it. Okay?